Alright, so we're on section 3.4, solving problems with acute triangles. First, before we get into solving problems, we need to define what an angle of elevation and an angle of depression is. Okay, so an angle of elevation is this angle down here looking up. So it's between the hypotenuse and the horizontal. That's what an angle of elevation is. An angle of depression is the opposite. So an angle of depression is right there, okay, and it's looking down, and it's between the horizontal above and the hypotenuse. So that's the angle of depression. A lot of people will make the mistake and put this as the angle of depression. That is not the angle of depression. The angle of depression is right in there. Okay? As you can see, the angle of elevation right there and the angle of depression up here, they're alternate interior. So they are equal to each other. And the reason being is because those two angles are alternate interior to each other. Okay, so let's look at an example here. Example 2. Determine the angle of depression to the nearest degree for each security camera located at point A and point B in the diagram. Okay, so what we need to find is we need to find this angle right here, and we also need to find this angle right there. Okay, so we're gonna have to break apart this triangle. As you can see there, we have one big triangle and then we have two smaller triangles. Because this is a right angle right here, that means that over here on this side, this is also a right angle triangle. So let's start by redrawing just this triangle to the left here, down below. Okay, so this is this triangle up here, redrawn down below. We have the right triangle, we have the hypotenuse is 4.8, and this side is 4.5, and we're trying to find this angle right there. Okay, so because it's a right triangle, we can use our primary trigonometric ratios, SOHCAHTOA. Okay, so first we need to label. This is the opposite side because it's opposite from the angle. This is the hypotenuse and this is the adjacent side. So what two sides do we have to work with? Well, we have the hypotenuse 4.8 and the opposite. So opposite over hypotenuse, that's going to be sine. So sine theta equals opposite over hypotenuse. Sine theta equals 4.5 over 4.8, which gives us 0.9375. And then to get theta, we do the inverse sine. Which gives us 69.6 degrees. So we found one part of the question. Okay, angle A, the security camera at point A. We need now to find the security camera at point B. So what we need to do is we can draw this. There's a couple ways we can do this. I'm going to choose to show you the method using the sine law. So I'm going to draw this whole big triangle A, B, D down here. Okay, so this is the triangle ABD from up here, okay, and we know that this angle is 69.6, this is 12, this is 4.8. We're trying to find out this angle, and we're missing this side, little a. So what we have here is we have a side, an angle, and a side. That's an SAS situation. So we can find out this side, little a, by using the cosine law. So which is a squared equals b squared plus d squared, the two other little sides unknown, minus 2bd cos of a. And then we fill in the numbers. So a squared, little b is 4.8. Plus 12 squared minus 2 times 4.8, and then the angle cos A, remember angle A is 69.6. Okay, so then we get that A squared equals 126.885. And then to get A, we just need to square root this answer to get that little a equals 11.3. Now the reason we needed to get little a, okay, now that we know little a is 11.3, the reason is because now we were able to use the sine law. So we have angle A and side little a, and we're trying to find angle B, and we have side little b. So we can write out the sine law as a over sine A equals b over sine B. Then we're going to fill in with our values. So there we go, 11.3 over sine 69.6 equals 4.8 over sine alpha. So now we're going to cross multiply. So multiply these two and divide by 11.3. Okay. So then we get that sine. So pause the video and try and cross multiply and see if you get the same answer I do. I got sine alpha equals 0.398, and alpha is going to be equal to 23.5 degrees. Okay, here's another type of problem. We have two triangles here, right? Kind of like a 3D model, sort of. And we need to find height AC right here, the x. Okay, so what's my strategy? Well, notice that this triangle ABC is a right triangle. So if I find out what BC is down here from this triangle over here, then I can use it, since I have an angle and a side, to find out what my unknown AC is. Okay? So how would I go about doing that? Well, how do I find BC? Let's redraw this triangle down here. Well, there it is, the triangle redrawn. I know that this angle is 50, this angle is 60, this whole length is 60 meters. So I think that I'm going to use the sine law, except for that I'm missing this angle up here. But we know that all angles in a triangle, this one plus this one plus this one, have to add up to 180. So that makes this angle up here 70 degrees. Now I can use the sine law because I have this angle and this side. And I'm trying to find, this is B, this one over here was C, and this was D. Alright, I'm trying to find BC, so I'm going to use this angle and that opposite side. Okay, so let me write out the sine law. Sine 70 over 60 equals sine 50 over D. Now I'm going to cross multiply. So multiply that, and then divide. So you guys try it on a piece of paper right now. Pause the video. D sine 70 equals 60 sine 50. And now I'm going to divide both sides by sine 70. So on this side we cancel out. So I get that D equals 48.9. Sorry, let me rewrite that. Now don't forget that D, this little d that I found, is actually equal to BC, this side up here. Okay, so now since I have a right triangle, I can use regular trigonometry. Let me redraw the triangle up here, or down here, one sec. Okay, so down here is my right triangle from above. This right triangle here, I've now redrawn it as triangle ACB, and I've discovered what this is right there. Okay, and now I can just use basic trigonometric laws. So I have this angle right there is 76. That makes this the opposite side, makes this the hypotenuse, and it makes this the adjacent side. So I'm going to use adjacent and opposite along with my angle from SOHCAHTOA, that's O over A, that's tan. So tan 76 equals opposite over adjacent. Now remember that since we have a fraction on the right side, we also need a fraction on the left side, and it's always going to be over 1. And now we just plug in our numbers. So tan 76 over 1 equals x over 48.9. And then we're just going to cross multiply. And we get that our missing piece, our height, x, is equal to 196.1. Now let's not forget our units. Let's go up here. We see that it's in meters, so the height is going to be in meters.